What is an oscilloscope? I want to fix this board, but we can't see electricity with our naked eyes, can we? So that's a problem, unless we talk about plasma. Basically, electrons ionizing the air. But even so, even if we can see electricity, the things here are happening so fast that we can't understand anything. And that's the problem, the speed of electricity. Have you ever heard about megahertz or maybe gigahertz? Well, those are measurements of speed, actually frequency. But anyway, those are speed of electricity where the electricity is oscillating like millions or even billions of times in 1 second. And that's way too fast for us, so we couldn't understand anything. And that's where the oscilloscope enters. And today I want to explain you what is an oscilloscope, and I do that for two reasons. First of all, because a lot of people around me, from my family or friends or even people on YouTube, are always asking me, what is that screen that you have on your videos? So I always have to explain them. And second of all, is because of the Keysight event. They're launching the new HD3 oscilloscope, and I can't tell you much about that. I think that I will be posting this video on 4th September, and that's the day they will release it. Until then, the only thing that I can say to you is that it's a new scope, and it will be awesome. Also, you have all the links for the events below the description, so join the events in order to unveil the secret text, and stay for live Q&As, also to watch the scope in action, and also some more surprises. And that being said, let's get started. What's up, my friends? Welcome back. So what is an oscilloscope? Actually, the most common name is just scope. Well, this one is from Keysight, and as you can see, it has a screen, so we can see what we are measuring. And then we have here 4 inputs. Not all the time we have 4, but in this case we have 4 inputs, and usually these are BNC inputs for our probes. And with these probes we can just test around and measure stuff. But what can we measure with an oscilloscope, and why we need it? And also why we need so many buttons? Don't get scared, it's not that difficult. So what do we use this for? And I think that the easiest way to understand the oscilloscope is to compare it with a multimeter. And I'm guessing that most people know what a multimeter is. You see it all the time when you go to the mechanic, or when the electrician is fixing something around your house, you see this multimeter. And this can measure a lot of stuff, but the most common is voltage. As for example, the voltage of this battery here. I connect the red one to positive, the black one to negative, and I get the voltage, which is around 12 volts, right? That's pretty basic. But this is a stable voltage. I mean, it's just a battery. Its voltage won't change that fast, so we can notice it. But what if I change the voltage like this very fast? As you can see on the screen, I'm getting random numbers, so we can't understand anything that happened here. If I want to see those changes in voltage, I need another variable. Now, an oscilloscope also measures the voltage, but this one uses another variable. Also takes in consideration the time. So you can see the voltage, how it's changing over time. And that's very important. Actually, this multimeter is pretty amazing. It can measure voltage, resistance, capacitance, inductance, also frequency, temperature, diode mode, a lot of stuff. It can measure a lot of stuff. But the oscilloscope can only measure voltage. So then why is the oscilloscope a lot more expensive than a normal multimeter? Well, let me tell you why. So that's what the oscilloscope does. It samples the voltage and also displays that voltage. It graphs it on the screen so you can see it. So you can understand all the changes that happen in that circuit. And talking about speed and time, this one is of 2 gigasamples per second, so basically 2 billion samples in just 1 second. Imagine that, that's a lot of speed. But the oscilloscope has a few more secrets, so let me tell you how to use it. Okay, so let's start. The same as with the multimeter, we have the black and red probe. In this case, we have this probe here. And it's connected to one of these inputs. As you can see, we have 4 inputs, and each one with a different color, and that's because it's very easy to use in that way, because the color of the input is also the color of the line that you will see on the screen. Also, the probe, as you can see here, has this color, yellow in this case, but I have another probe here that has a green color, so you know which probe will go on each channel. And that's very easy to understand when you are working with multiple channels at the same time. Now usually this one from Keysight has 4 channels, but usually you see it with 2 channels or maybe even 1, 4, 6, it doesn't matter. This one has 4. And this for me, for example, it was very useful when I was working on the project of the ESC, because I had to see the feedback from each of the triple phases of the motor. So I've connected the probe, three probes in that case, to the faces of the motor, and as you can see on the screen, I can see the back EMF from each of the probe, and I can make the calculations and the maths in order to get my formula, in order to control the PWM signal that will go to the motor and so on. So it's a lot easier to do that when you have more than just one or two inputs. And this would be the probe. As you can see, it has a hook, so you can grab wires with this, or you can just remove this and it has a point, and you can test things on your circuit with this point. And on the other side we have the ground connection, and basically this represents the black and the red wire from the multimeter. You connect this to ground, and then you connect this to the signal that you want to analyze. And on the other side, actually, we have the BNC connector, and this is not just a normal coaxial cable. It also has a small circuit inside and a capacitance that you have to change the capacitance in order to match the capacitance input of the oscilloscope and so on. But that doesn't matter. It's just a more sophisticated cable than just a normal cable as the multimeter. Okay, so now we have the probe, so we connect our signal. And on the vertical, we have the voltage value, and on the horizontal graph we have the time, and then we have a bunch of buttons. And by the way, on the Keysight scopes, any button that you long press, it will finally give you what's the purpose of that button. So just push them around, keep them pressed till you have this message, and just see what each of these buttons does. But don't get scared, it's very easy to use an oscilloscope. Okay, so now we have our signal, but then we have two knobs here on the horizontal line and two more knobs here for the vertical line. These two are for controlling the scale and position of the horizontal line, which is the time. So as you can see with the big one, I can zoom in and zoom out, basically changing the time division so we can know the time of the signal. And this is for all the channels. But then we have these other two here, and these are for controlling the vertical line, which is the voltage. So basically I can go in and out on the voltage. I can make it bigger or smaller. And also I can change the position with the other knob. The same way as I can do with this one, I can change the position of my signal on the horizontal line or on the vertical line. So that's what we use these knobs. But these two are for all the channels. We can change the time scale for all the channels, but these two are for each specific channel. As you can see right now, I selected the yellow line. So as you can see, if I move with my cursor, I'm moving the yellow line. But then if I select this one, which is channel 2, it will appear the green line, and now if I use that knob, I can control the position of the second channel, and I can do that for the third channel and the fourth channel. So these are for all the channels, and this is for each specific channel. That's what we use those knobs for. Okay, so now we know these four knobs, but then we have this one here, which is the trigger knob, and this basically creates a line and tells the scope on which point of the signal we want to trigger that signal. Otherwise, the signal will just be wobbling around. We want to stop it and show it on the screen so we could understand it. As you can see, if I use this knob, you get that line, and if I move it upwards, it changes the position where the signal is triggered. If you want to trigger it here, maybe here, maybe here, and if you go at the maximum point and you get out of the signal, as you can see, we lost tracking, and the signal is just wobbling around. So this is the triggering button. You have a lot more stuff for triggering, like the fall of edge, if you want to trigger signals like square wave. And as you can see, if you go on trigger type, you get the source, which in this case is channel 1, but you also have the slope. For example, you can change it from rising edge, or falling edge, alternating, or either of the edges, when it goes upwards or downwards. Another thing that I wanted to show you is the stop run button and the single one. And this is related with the trigger button, the trigger settings. If you leave it on run, which is right now on green, then anytime that your settings for the trigger are accomplished, it will trigger the event and it will stop the image. As you can see, if I click it here at the same frequency, it will stop the picture on the screen. Basically, it will show me the signal anytime this trigger will happen. But if I place it on my battery and I want to see the signal, and even if I disconnect it, I still want to see it, I can place it and then press stop, and it will keep that exact moment in time. So if you're seeing a signal that you like, you can just press stop and it will stop it on the screen. Even if I still continue to change the signal, I will still see that signal there. But then we have the single button. If I press this one, it won't show anything on the screen, and it will wait till the settings for your trigger will be completed. So for example, if you're waiting for a specific signal to happen, at that exact same moment, if I touch it, as you can see, it made the trigger just one snapshot, and it will show me at the screen. As you can see how the voltage is charging from 0 to the voltage of the battery. So if I want to see that charging process, let me just press it once again. Exactly that moment, when I touch it, it will trigger it and keep it there. So you have the run, stop button and the single one for just a burst of signals. For example, like if you are watching a night square C communication or something like that, you just press it once and then you get the entire signal on the screen. And you can place the settings for how long it will record from the signal and so on. And these two buttons are also very important. Okay, so now we have our signal on the screen and we can see it. But now we want to measure it. We want to see the time that it takes to rise and fall. We want to see the frequency, the voltage that it reaches. So how can we do that? Back in the days with the analog oscilloscopes, let's call them analog, we used just a ruler, and also as you can see on the screen we have some squares. And we know the scale that we are in. So basically each of the square represents like 1 division of voltage, 5 divisions, 20 divisions. So just by measuring that, so using the ruler, we can measure the signal, we pass that data with pen and paper, we then make the calculations and we get the math. But that's the old school. Nowadays, we have the math button. And if you press it, you have a bunch of functions and you can measure anything that you want from this signal. Okay, so I'm generating a sinusoidal wave here. You can change because this oscilloscope also has a signal generator. Let me just generate maybe noise. No, let me just generate a sine wave and just put it to 500 Hertz. So this is our signal. We can also apply auto scale and it will scale it automatically to the best scale that we have. Actually, I like it a little bit bigger. So I have my signal, but I want to measure the voltage that it reaches, the time between pulses, which will be the period, the frequency and so on. So I press the means button or the measurement, and as you can see, automatically places the frequency or peak-to-peak voltage. But let's say that you want a different calculation. You click the type 1, and here, as you can see, we have a bunch of measurements. Starting with voltage, for example, you can select the maximum voltage. It will place it here, max 4.28 volts. Let's add another measurement. Let's add the frequency, for example. This is the frequency. We add it. We have the peak-to-peak, the maximum voltage, and the frequency, which is 500 Hertz, which is the frequency that I've set. Let's add another measurement, maybe the width of the pulse. In this case, it's a sinusoidal, and as you can see, it already appears with the cursor, and it tells you that it measures the pulse from here to here. But if I change this type of pulse, maybe to pulse or a ramp, a square wave. As you can see, it measures the pulse duration from here to here. Actually, when you add the measurements, you can also make some settings. For example, if you want to measure the pulse from here to here, or maybe add another measurement, which is the width for the inner pulse. So not the width here, but the width here. Anyway, as you can see, we have a lot of measurements: DC, RMS, AC RMS, the width, the duty cycle, the rise time and the fall time. We have the delay between signals, so you can select channel 1 and channel 2 and see the delay between the signals. We have a lot of calculations here, so you don't have to do that with pen and paper. Just press the mean buttons and that's it. Oh, and by the way, nowadays oscilloscopes have a USB input here, so you can place an SD card here or USB stick and save a picture of this on your drive. And you also have this save to USB, but if you go here on means and you get to type, as you can see, we have the peak-to-peak maximum, but this at the top is a snapshot of all. So if you place that, it will place on the screen all the measurements at the same time. So now if you press the save to USB button, you save the graph, the snapshot of all your measurements. This is so cool when you want to work then on a project. So you make the measurements, you save it to the SD card, and then you have all the measurements to place them on Excel or any other application that you want with it. Then from the same measurement chapter, we have the second button, which is cursor, and if you press it, as you can see, you get one cursor and you can fix it on the point that you want to measure. And this is for more random signals that are not repetitive like this one. So let's say that you want to measure exactly from that point down to this point here. So place it here on the point that you want to measure, you change to X2, and then you move the other cursor down to this point. And as you can see, you can see the time for each point. So you can measure the time from here to here, not the entire period. And you can also do the same for the y-axis. So as you can see, we have another cursor here, or you can move them at the same time for the y-axis or for the x-axis. As you can see, we can move them, and you have here the time difference or the voltage difference. So this is also very useful for those signals which are not repetitive and you want to measure exactly from this point to this point. You can even zoom in and then just make it a lot more precise. Okay, so for now you know how to move around with the knobs and observe your signal. Then you also know how to use the calculation, the math button and the cursor to make measurements. But once you have the measurements, you have to use those signals. Let's say that we now have connected channel 1 and 2. As you can see, we have two graphs here. But let's just imagine that with one channel we are measuring the voltage from a power supply, and the other channel is connected to a probe for current, so we are measuring the current at the same time. So with that, obviously we'll get, if you multiply voltage by current, you get the power. So you will get the power that is outputting from that power supply at any given moment. But you have to make the calculation on each specific time. So you get the value, you place it on paper, you make the calculation. You get the value, you place it on paper, you make the calculation. And that will take a lot of time. Luckily, nowadays we also have another magic button, which is the math button, the button here. And if you press it, you'll get once again a lot of calculations for working with the signals. You can get the FFT, you can get the multiplication, you can subtract one signal from the other, you can interpolate, can make interpolation and a lot more. So let me just show it. Okay, so we have our signals. Let me just show it to you. This is channel 1, we activate channel 2, and this is channel 2, a square wave. So let's just imagine that one is voltage, the other one is current. Let me just make a small zoom here. So now we have our signals. If I press the math button, as you can see we get here, let me just change the brightness here. As you can see, we get the operator, and we have add, subtract, multiply, divide, Fourier transform, and for phase and magnitude, and low pass filter. If you can see, I select the add one, and you get another curve, which is with like purple color, and that is in real time the sum between the green one and the yellow one. That's so cool. And if you want to say, for example, get the power, you get multiplication. So I select multiply, which is this one. And now the purple line is the representation of the power at each given moment, because it's the multiplication between the yellow one and the green one. And as you can see, if I press this button, I can also select from which channel I want to make the multiplication. So for example, I place channel 1 here, but on the other one I place channel 3, which is right now not connected, so we will get this. But if I select channel 2, it will make the multiplication between these two signals. We can also divide the signals, and then we get the fast Fourier transform, which is for a different chapter. But there is more. Now I have selected the multiplication, so we get the purple line, which represents, in my example, the power. But then you can also go to the mean button, to the measurement, and once again, if you select source, now it's on channel 1, you also get the math source. So it's this line here. So if you select that, now if you can add the measurement, it will be for that multiplication line. So let's just get the, for example, the peak-to-peak value, and you get the peak-to-peak value of the math result that you are making. So you get actually the power. As you can see, is 10 volts squared, because it's multiplication between voltages. But imagine that this will be voltage times current, it will be 10 watts. So that's how easy it is to get measurements on your scope. Okay, so the last button for measurement that I want to show is the FFT, or fast Fourier transform, and when you activate it, as you can see, you get all the spectrum of frequencies. Let's just imagine like radio frequencies. It could be more than radio, but let's just imagine that. So this is just the spectrum in megahertz or kilohertz, and now we have connected our signal, which by the way comes from the generator, and it is at 29 kilohertz. So basically we have a line just down here at 29 kilohertz, because that's a very low frequency value. But look what happens when I increase the frequency. So my signal gets faster and faster. As you can see, it appears a line here. Let me just make a zoom in. So right now I'm at 860 kilohertz, but if I increase that to megahertz, the line will also move into the spectrum, because this is the entire spectrum, and as you can see, the line moves. So this just imagine that it represents like the radio signal for your music or news channel, and each one is at a different frequency. And this is the spike and all the harmonics. So that's what we use the Fourier transform to see the spectrum of frequencies, not just one frequency. And as you can see, if I move it around, this line here will also move around from the beginning to the middle. And that's the FFT. And now things to have in mind when using your oscilloscope. And first of all, for safety reasons, you have to know that this is actually ground of your oscilloscope. So this is connected to the ground, and the same ground that is shared with your main power input. So if you connect this to your main outlet, it's sharing the ground. So if by mistake you connect this probe, which is the ground, to the face of the power outlet that you are measuring, you connect a short circuit between your face and ground of your home, and your breaker will jump. And if you don't have a breaker, it will make a short circuit. So be careful with that. You can't connect this ground to any wire that you want to measure, especially for high voltage. If you're measuring something like an Arduino or 5 volts, that doesn't matter. But if you measure like mains outlet and you connect this ground to phase, you basically connect the ground of your home with the phase, and that will be a short circuit. Another thing that a lot of people is doing when measuring like 2 signals or more is placing one signal on the upside and another signal on the bottom side in order to see them at the same time. But that's a bit wrong, because the more space you occupy on the screen, the ADC will work better because it will use the entire range of the screen. So basically what you want to do is to go on channel 1 and make it as big as possible. It will occupy the entire screen. You just see like this. And then to go to the second channel and also make it to occupy the entire channel. And if you want, you can just move it around or just activate one at a time and then activate the other one in a different time. Because otherwise you'll just use a small part of your ADC. Okay guys, so this was a super basic introduction to oscilloscopes, and I hope that you understand it. And actually the best way to understand it even more is to just get a scope and start a project and start testing around. Always taking care of the voltage that you're touching, not making short circuits, and also check some tools that you can use. For example, for your probes, you have your normal probe, which is this one with the hook, but you also have a more smaller one. As you can see here on the probe, we have the tip and also this, which is also connected to ground. So you can have just a small clip for very short connections on your PCB, and that will also minimize the noise because it's a very small connection. And then you can just play around with the voltages and the signals that you are using, with the fast Fourier transform, with the mathematical operations, and just play around, especially with digital signals like I2C, maybe SPI. Just test them around, get an Arduino, connect it, and just play around with your scope. And by the way, remember to check the links for the Keysight event because it will be very interesting. I hope that you like the new scope, the HD3, when it will be launched on the market. It will be awesome. I can't show you more, maybe just some pictures. I can show these pictures for now. But on 4th September, it will be official launch date, so you can see it. And also a lot of more secrets. You can get the secret text and discover what they want to say to you, and some more Q&As and a live video with the scope, how they're using it and for what you can use it, and maybe some more secrets, maybe a giveaway, I'm not sure. So yeah, check the links below. And as always, thanks again and keep up, you guys. And now I leave you with how I found out about the HD3 oscilloscope. I'm busted, they catch me.